All right, good morning. How's everybody doing today?
All right. All right.
Very
Doing
good.
good. All right, awesome. So we are here. Good morning, everybody. I see people hopping in. So I'm going to give everybody about a minute or so before we kind of dive into things. But as you can see, we are here for AtomBeam's webinar. Um, and happy to be here, happy to get going.
Yep. Same here. No, glad we could set this up. And we've had a sort of a unusual gap of a month. We usually every month we knock these out.
Mhm.
But this last month has been so over the top that it was hard to fit it in. But we will be doing a monthly on ongoing.
Exactly, exactly. And if for whatever reason you're not able to see it, we will post everything as recaps and, answer any questions that might not happen. So I'll kind of jump into it. Welcome to today's webinar with AtomBeam. My name is Jeanette Cornish with Digital Niche Agency, and I am happy to be your host for today's event. Joining me is AtomBeam CEO Charles Yeomans and Julien Dersy, Vice President of Product Management and formerly Inmarsat Vice President of Product Management. On today's webinar, we will explore the revolutionary technology reshaping data transmission and storage, gain insight into AtomBeam's journey from inception to its current state of product development. At the end, we're also going to hold a Q&A section to answer any questions. And then, as some of you may know, we are currently having reservations on Start Engine. So I do need to read a disclaimer, and just to make everything clear of the status. So no money or other consideration is being solicited, and if sent in response will not be accepted. No offer to buy the securities can be accepted, and no part of the purchase price can be received until the offering statement is filed, and only through an intermediary's platform. An indication of interest involves no obligation or commitment of any kind. Reserving securities is simply an indication of interest. So
And
without further ado, Charles, I will pass it over to you.
all right, very good. Thanks. All right. So thanks for that, Jeanette. And good morning, everybody. I appreciate everybody's coming. We have a record crowd today. It's pretty cool and exciting that the world's waking up and seeing what we've seen for a while, and a bunch of you guys have seen for a while, which is, this is pretty cool, game-changing stuff, and there's a lot of potential here, and it really comes down to the execution. And I got to tell you, one of the key guys for us in actually executing on this really incredible potential, but to turn it into something real. I mean, there's not many things that have this much potential, but there's a lot of things with real potential, and it comes down to execution. It comes down to turning it into something that's a real company with real customers using a real product. And speaking of that, Julien here joined us. He was, I think I could call it, a fan of the company when he was at Inmarsat. And he has come on board with us in the role of the king of products. And we're going to explain, or he's going to explain exactly what that means. But Julie, you want to talk about your background a little for us, please?
Yeah, sure, Charles, and thanks for the introduction. And I totally agree. I think the product is super exciting. I've never faced such a product. It looks quite simple on the face of it, but or we'll go through more details. But its applications are endless, and sometimes when they have such a product with so many applications, it's always very difficult to stay focused on the one thing, and that will get you started and make you successful, and whilst at the same time building all these other exciting things. And in terms of my background, I've been doing products in tech industry for quite a while. My background is engineering background, software engineering, but also general engineering. And I've spent a few years at Inmarsat doing all their products across all the verticals, whether it's for aviation, maritime, enterprises, or governments, and which is related to satellite communications all around the world. And prior to that, I spent 5 years at Amazon working on the Amazon platforms, and Amazon is just great for doing
Amazon
projects
Web
at
Services,
scale.
just to be clear, make it. I'm saying, it's not everybody is going to make the distinction between Amazon, where you buy toothbrushes,
Absolutely. But it's all about the scaling and the infrastructure and how you launch products at scale. And at Amadeus, doing IT for travels, but deploying systems in airports. And I had built quite a few products from scratch, which more than 10 years ago, which are still ongoing, and they built upon those products and delivering more and more and making life of passengers and airports a lot easier. So very proud of what I've done there, and I'm very proud of joining AtomBeam. And I think there's going to be lots of exciting stuff we're doing. So
go ahead, fire away.
So you're wondering what product is about. So, I mean, product is kind of the confluence of all the different parts of the company. As product, you have to be able to wear lots of different hats. But the point is that, you collect a lot of inputs from your engineering, from the research, the sales, the marketing. And it's about it's a teamwork, but it's also about condensing all that information and then re-articulating it back to everyone and say, okay, based on all the different inputs, this is what the product needs to be. One key thing that you get from marketing and sales is the customer input. And in fact, as product, we often also hand in hand with sales and marketing go and work with customers to really get deep to understand their needs and then articulate the customer needs back to the research team or the engineering organization, and in articulating it in a way that they understand. So as product, I have to be able to talk to customers in simple terms, but also have to talk to engineers in very complex technical environment, technical terms, and giving them the reason why customers need to do things in a certain way. And so a lot of organizations nowadays move more and more towards a product-led organization because of the need to deliver products for customers.
Right. It really comes down to, somebody has to be the central locus of all the coordinating hand for saying, okay, I have an input from sales that says this oil company needs for this to be in the product, this feature, this whatever it is, or the product needs to be able to operate in this given environment. And then that gets to Julien, and it gets translated perhaps down to research to say, work on this feature or work on this aspect of the product. And then finally to production engineering, which in production says, oh, okay, I know what I need to do. I've got the prototype built by research, and now production engineering can turn it into an integrated, tested part of the product. Is that fairly stated?
Yeah, and the inputs can come from sales, but there's also take inputs from the marketing research,
right,
understanding what we see in the markets as well. And so it's a lot of trade-offs. And yes, if the request from sales is affecting a large market, then definitely we'll jump on the occasion. If it's a smaller market or uncertain, maybe we need to do a bit more market research. Maybe we need to do a bit more research on the functionality. So it's really articulating and understanding how to prioritize those things.
Right. Thank you. Okay. So before Julien really gets into kind of what he's been doing and what the company's been doing in terms of product, I want to give everybody a quick update, what's going on with the company and all that. So the first thing to mention here is that the beta that we did kind of a soft launch starting in December. And, we are working with a couple of customers in particular, such as Julien's former employer, that is, say, Viasat / Inmarsat, but also with, soon just beginning with several other companies. And the sales guys are bringing those to the table, and then we're working with them to work on the product, which again is being coordinated by Julien. And the beta is in really very good shape now. It is a lot of the things that are being done is make the user interface more friendly, do things to make sure that everything in the back end has been thoroughly tested, things like that. So that should be released end of next month, right, Julien? That's
and yeah, I get into more details
okay.
later on where we are at. We already got some customers with getting their hands on the product.
Right. And then Neurcom, in which Julien will talk about a little more, is getting a lot of, that's earlier stage, but it's getting a lot of effort being applied to it. And it's looking just as promising as we have long thought it was. And on both of those products, the Space Force and the Air Force phase 2 efforts, the $1.2 million each, we're deep into those. Both are going extremely well. We'll talk a little more about it, but those efforts, the goal is to get to a phase 3, which is also just called a standard contract, and that's the big kahuna. And we also have been, and this is particularly what I've been doing, is building out the board, which we're going to be announcing next month, probably. Yeah, almost. Yeah, we'll definitely announce it next month. The board of directors and the new team. So it's a lot more than it used to be, and it's a formidable group of people. And I think as you will perceive as Julien goes on, he's an example of the kind of really high quality people that we've attracted. It's just very satisfying. And our goals for this year is getting the SaaS release, getting customers onboarded, and getting hardware, getting built into hardware. We're working with a couple of companies now that Julien will talk about in a little bit on building it into those, and also moving forward with chips. We intend to do all of that this year. And then also seeing if we can get land some more phase 2 contracts with DoD and the intelligence community, the IC as it's called, and also finally, as I mentioned, getting a phase 3. So those are the big goals: getting customer revenue from commercial rolling, and getting ourselves into the hardware, and also getting some serious revenue coming from the government. So with that, I'll turn it back over to Julien.
Yes. So, I don't know if you've all seen, but we know data has been growing rapidly, and it's actually not going to abate. And if anything, now with the advent of large language models and generative AI, Gen AI, the hunger for data is becoming more and more, and the amount of data that's also being generated, it's just increasing at a dramatic pace. And in fact, there's the interesting things around these statistics that you'll see is probably in 2025, there'll be, I think, something along the lines of 90 zettabytes of that data being generated by IoT. IoT is the Internet of Things, small devices sending lots of small messages. The amount of data that's generated by those devices nowadays is becoming so significant, and the networks they operate on often are constrained that we can't pass all the data through the networks, and especially in sort of remote areas. And this is where satellite comes in, but there are other technologies as well. And then you get into, even if you pass the data, how do you store that data? And there's huge amounts of data. So the net result is very often you have to filter the data, which means is another word for throwing away the data. And this is where where we think we can make all that data a lot more efficient. The way the data is generated by the machines in IoT is very repetitive, and this is where AtomBeam comes in and can make all of that data generation a lot more efficient, and therefore can be transported in near real time, and allows for decision driven activities and actually power AIs as well, and to drive more decision making for companies and in all sorts of other areas. And not only that, it's just the way we store the data as well makes it still accessible. And I'll touch into a bit more detail. But the point is, data is just exploding. It will carry on to explode. It's not going to get anywhere. It's not going to slow down. And we need to do something about it.
Yep. No, I mean, and if you think about the scale of this, I mean, those, yeah, just like little blocks, and you say 175 of anything doesn't seem like that much, but it's, I mean, 2010 wasn't that long ago. And 2010, 2 zettabytes is the entire capacity of the storage capacity of all of the data centers in the world combined is 2 zettabytes. And you say, well, wait a second, next year we're going to be at 175. Where is it all going to go? Well, as Julien just said, it's going to be quote unquote filtered, tossed out, most of it. You know, a lot of it, it's just too much for them, for anybody to do anything with it, to use it for something useful. And as Julien was just emphasizing, you have to have, the IoT is really just getting off the ground now. And the amount of efficiency and decisions making that's better and everything that can be made to happen is going to start to really kick in. But in order for that to happen, a lot of that data needs to move from A to B, and the networks are like microscopic compared to the amount of data that needs to move. And so that's where we come in, and it's a giant opportunity because of that, in part.
Right, absolutely. And that's putting a lot of cost pressures on those companies. And also these companies in terms of the manufacturing or the agricultures, all of these also are under a huge amount of pressure to improve their efficiency, improve their performance. And also you probably hear about more and more sort of data regulations, you know, GDPR, and also you hear about the breaches around the data being stolen. So there's a lot going on and moving parts that the companies had to deal with. And clearly, the bigger the data they have to move around and deal with, the more difficult it gets. And this is why we can help those companies become more efficient, make those investments they'll make in technology a lot more provide a higher level of return by just, you know, making all of that data smaller and easier to move around and to exploit.
Right.
And so, you know, the reality is today, if you look at the data, I mean, there's a sample of data being transmitted by some IoT devices. A lot of these messages are repeat the same information over and over again. The data by all these devices is siloed. Each device is sent their own data. It's inefficient, and as a result, it becomes costly. And this is where compaction comes in to make it smaller and more efficient. And there's a big difference between compaction and compression, that compaction will do it on the fly, will do it as the data flows through, as opposed to compression, which takes the entire file and has to reorganize the whole file, restructure it, and then pass it on. So that's the big difference between a compaction and a compression. And so it's not just it makes it smaller, but also because of the way it does it on the streaming basis, it also can make it still accessible and retrievable, as opposed to compression, where you have to unpack the whole file to see what's inside and be able to exploit the data. So, but AtomBeam, you know, we've talked about compaction, we've talked about IoT. So this is how AtomBeam started, and you know, our compaction process is a lossless compaction. So whatever data you put in is reduced. When you take it out again, it stays intact. Another activity that AtomBeam's been working on is Neurcom, which is more focused on images and video and audio. And those types of compression are what we call lossy compression. And so it's typical, if you know your images JPEG, and the way it compresses it, it takes advantage of the fact that the human eye is sensitive to changes in light, but less sensitive to changes in colors. And this is how they're able to make images smaller without you noticing it. But Neurcom is there to actually improve on these sort of codecs and compression algorithm, and to make them even 2 times more efficient. So it supplements those image and video compression technologies. And the amount of data that's also generated by video and images is growing at a massive rate. You can see all your phones have more and more cameras. Those small cameras they put on phones are now being put on all sorts of other devices just for monitoring, even in factories, in plants. So it's also another source of data that we're doing a lot of research on how we can deploy that technology out in the field. And really, the way, if you think about it, yes, we talked about IoT and long distance compaction, but that level of compaction could be even happening on the board between chips. These are the future that we're trying to enable. But before we get there, we'll try and make the solution embedded on hardware so that it's easier to deploy. And then, later on, hopefully we can go into more the chip world, but that's a big, massive step before we get there.
Right. Yep. No, and I want to emphasize, and we're going to talk a little about this, but I want to emphasize that the cool thing about partnering with companies that make gadgets, make devices, and it could be an F-35 from Lockheed, but it also could be, somebody who makes little boxes, they're called gateways, that connect to a bunch of sensors and send the data somewhere. So it's a gamut, it's a whole range of things. But if we partner with the companies that make the boxes, they have something to their advantage over their competitors when they sell it. So if you said to somebody who makes gateways, which in fact we're saying, and they are listening and they're actually all over it, if you buy my box, you can send 4 times more data, or you can cut the amount of data you're sending by 75%, which means that whatever the cost of transmission could be cut, or you can just send a lot more data that you couldn't send before, or it's faster, or it's more secure, or whatever it is that floats your boat. It's a big deal when we go to those manufacturers of those hardware devices and they see a significant competitive advantage. And so I don't recall talking to anybody who makes those devices who hasn't had pretty strong interest in our stuff. Why? Because if they have it and their competitors don't, that's a huge advantage. Or if their competitor has it and they don't, they need to get it. So it's something that we're counting on, and it seems to be working in terms of like the go-to-market strategy.
Yeah. So what's the difference between Neurcom versus compaction? And so, Neurcom is a lossy process. It applies to lossy codecs, and it applies to primarily video, images, audios, and there's more and more types as well from satellite, from Earth, what we call Earth observation, which are used more and more for, monitoring climate change and, helping us deal with that problem. So it's becoming even more and more important that, we can get all of that data back and analyze it in a timely manner as well. Whereas compaction, really applies to data and in a lossless way. So it means you make the data smaller, but when you expand it back at the other end, it looks exactly the same that it was in the first place. And it's usually, will be applied for telemetry, what we call sort of machine generated messages, tracking control, and, all sorts of other business data. I mean, but to be honest, we've applied compaction to PowerPoints, to Excel. We try it on all sorts of different things, and it's giving us good performance on any sort of data that you could store on your hard drive, for example. But the reason we're going for IoT and telemetry is because compaction is uniquely able to reduce those telemetry messages, which a traditional compression couldn't do because it needs a minimum size of payload. It needs a minimum. On average, we compared it at 2 kilobytes. The efficiency of compression drops, whereas the compaction remains super efficient, even down to down to a few bytes. So this is why for telemetry it's super important.
Right. And just to give you a sense, like with most like video codecs, that's what you call these compression algorithms that reduce things on a lossy basis for like videos, images, and so forth. With a video, the size of the file you start with compared to the size of the file after you've applied the codec, even to get to, high definition, is enormous. Like, and it's like 97% smaller, right? Something like that. And to get there, most of the reduction is not by compression as we understand it, which is taking things and replacing some patterns with placeholders. What we're doing in this case is we're just, what I should say, what the codecs are doing is they're throwing out most of the data. So Julien, you can expand on that if you think something.
Yeah, I mean, a lot of it also they throw out, like I mentioned, different color changes that you may not notice, but also they maintain, especially on video, they'll look for, you can see on this video, for example, the central ring, just shrinks smaller and smaller, so it's able to retain that information from frame to frame. So there's a lot of video, by the way, is just 25 frames per second or more, but it's still just a series of pictures. And what it does is it looks at what is the same in the following picture compared to the previous one, and so that's one of the ways they apply. They make it things a lot smaller.
Right. Yeah. So it's and you think, well, if you're getting rid of 97%, why would you need to do it anymore? Well, you're talking about still a really big file. You might get it down. It's like a movie might be 3-4 gigabytes or something. Well, that's still pretty freaking big. And if you can get it down from 4 to 2 or 4 to 1, then that's a major achievement. So, and the original size of these video files is massive. I mean, terabytes usually. So anyway, just moving on. If you want to talk some more about Neurcom, please.
Yeah, I mean, one of the things that the common theme across Neurcom and Compaction is that actually there are AI-based algorithms behind it. It's not just a simple algorithm like you have for compression. We apply AI because it's much faster at discovering those patterns and what needs to be done. And because nowadays we have access to AI chips, which in the past, they were, they were in data centers and so on. Now, your phones has an AI chip embedded. So it's becoming more and more ubiquitous. And we can apply those AI process to further enhance these codecs that were defined as a straightforward algorithm, if you like, and still achieve the same level of quality without adding further losses to the image quality or the audio. But it's still in research.
Yep. No, and there's the amount of complexity in this thing is, to say the least, a lot. I mean, I think it's probably some of you who were on a session we did, a webinar we did last year, in which we had the professor who's our partner on working on this thing, Professor Zhu Li. So he had originally sent me a deck that was tightly packed 70 slides that was going to be presented to the audience here. And I said, well, perhaps we have a little bit of maybe we eliminate some of these equations and stuff forth. So at any rate, but the bottom line is I mean, it's pretty easy to follow how compaction, the basic, I mean, there's some heavy duty math in this thing, believe me, but to understand the basics of how it works, you can get your head around it. To understand Neurcom, it's a little bit tougher, but at any rate, but go ahead, keep going.
Right. Yeah, I mean, but there is also another professor behind compaction as well in mathematics.
Yes, right.
So we do have a good support there. And this is but at least for compaction, we've been going at it for a little bit longer than Neurcom. So that's also another reason why. And you can imagine Neurcom images require a bit more processing power. So it's only right that we're doing it now with, and AI chips are going through the roof. You guys have heard of NVIDIA and their successes. And, I don't think they can produce enough AI chips. And now everyone is jumping on the AI chip bandwagon. There's been some recent announcements from Intel and other companies who are jumping on that as well. But so back to compaction and IoT customers, you have to realize IoT customers are facing new technologies. They're facing AI, large language models. They're not just Gen AI, they're not just chatbots. They are these models that are able to absorb a ton of data and correlate it, and then you can sort of query those systems and extract those correlations from those large models. So they're super important. They're being applied in all sorts of different instances. And so the list is ever growing, and it's only going to grow faster and faster. And then, you've got all the different ways. You've got the mobile, the explosion of 5G and space. And you've probably seen Starlink and have launched a satellite. They're able to already send messages to your 4G phone from space. And that's also growing at a rapid pace. Competition, obviously, there's more and more competition. So companies have to be as efficient and not just lowering costs, but also being able to do things faster and deliver faster and better as well for their customers. And the amount of apps and things is also proliferating. A struggle to keep control of the number of apps I've got on my phone, and let alone on your sort of smartwatch. So all of that creates a massive amount of scale and challenges and operating challenges for those IoT customers. And this is where we can help, make it at least a lot less painful for them if we can reduce those messages, those data, and not just the messages, but also the storage of that data by up to 75%.
Yeah, with retaining access to the data, the same to the computer as if it was not encoded. That is, it's hard to express how big a deal it is that the data that is encoded with compaction is still accessible to end users. I mean, and I know we always talk about reducing the amount of data that you need to send over a pipe, and that's a huge deal, but there are those who believe that the most important aspect of compaction is the fact that the data is accessible while it's quote unquote at rest, that is to say, in storage. It changes the game for every data center potentially in the world. I should mention too that I can see we're getting Q&A questions put in. We will address them. We are going to get through this, and then Jeanette will conduct us through those. All right, go ahead.
Yeah, so and the other thing is the way compaction works is the way we've got it set up is that we can get customers up and running in minutes. And that's why we've gone for a SaaS solution initially, is so that customers can get their hands on it immediately, see the value, see how efficient it is on their data, And then once they deploy it, they'll realize, it has a very minimal footprint on the CPU in terms both of memory and cycles that it would consume. It's just the way the technology works. All the heavy lifting has been done by the AI. Essentially, the AI will work out, what's the best way to compress the messages, to compact the messages, and then and the CPU just has to follow the instructions from the AI to say swap this huge pattern to this small thing, this small code word, and then that's all it does. It just swaps it out, but like I said, all the intelligence is on the AI to do that, and as a result, you also have minimum added latency to those messages. And in fact, if you have a series of messages you're sending through a pipe, lots of small messages, but they're all contending for that small pipe, because we're making them smaller, they all get through a lot quicker as well.
Yep. And just to be clear, when Julian's talking about SaaS, he's meaning software as a service, which is essentially when you have your software living in the cloud, in servers at Amazon Web Service or Microsoft Azure, one of those services. And then it's up to us, and it's pretty easy for us to maintain it, to improve it, to version it, to fix it if something goes wrong, all those things, because it's being supplied as a service, as opposed to here's a pre-packaged piece of software that you take and you install in your gadget. It simplifies everything for everybody, and it puts us into a position in which we can charge not just a one-time thing, but also on an ongoing basis. Even if we say we get into the hardware, into a piece of hardware, they still have to send the data to the cloud, and then they're paying for our service on an ongoing basis. So that's obviously a good thing from a revenue standpoint.
Yeah, and so really, I think compaction is unique, and especially the way AtomBeam's got it implemented. One is the uniqueness is the fact it's an AI, so you've got a big AI there on the right of your screen. But it's and the data reduction is done in near real time, and because of the way that AI works, the way we look at patterns, we can actually add not only we can add further encryption around the way we encode these patterns, but also because the AI learns what the data looks like, the frequency of these patterns and things, we can also use that to do intrusion detection, where we say suddenly there's a change. And so typically in an IoT environment, you could detect if someone is tampering with a sensor. So the sensor tampering, you'll detect it. Someone changes sensor to send erroneous data, whether it's all malignant or it was just an accident. So all that information can be used to alert users and customers so that they can take remedial action. And because of the way it's done, we talk about, okay, we can store the data, make it retrievable. And the reason it's because rather than trying to expand the data back to what it was when you search for your data, what we will do is we will compact your search query and go and search the data using the compacted form of your search query against the compacted data. So essentially, that's why we can do that, which you can't do with compression. So this is why it's so unique, and that's why we are keen to explore that avenue and bring people on board with this concept.
Yeah, and I should mention, so we're up to 36 patents now, and another 44 are pending. So I would call it prodigious in our production of patents. So, and
yeah.
Go ahead.
No.
Yeah, I was going to say, so the key thing for us in terms of, as I mentioned before, is we want to deliver up a solution that deals with all of your data, not just a little. And so one of the key things to get there is, how do you actually test it?
Yeah. And so what we've done is we've created a sandbox. So essentially, when you'll come to our website, you'll be able to create your the environment you need to use AtomBeam's compaction. But we've also, to make it even easier, we've created what's called a sandbox, where we'll instantiate the full environment, the full encoding, decoding piece, everything in one click. And then from there, you can just send your data to it, and you'll see exactly how much the reduction in data you get. So you can do that within minutes. And so customers will be able to evaluate their own use cases. They'll be able not only to evaluate how much reduction they get, but they'll be able to work and use the live system as it is, because the sandbox is just an instantiation of AtomBeam's compaction production system, just made easier for you. We created it for you. So once they've done that, they can quickly move to deploying that same environment in their lab. So they can then start putting it in a lab. It will take maybe 5 minutes to deploy in the lab. And then from there, they can then decide to start pushing it to their sort of edge devices and gateways and other places. So, and the purpose of the sandbox is to make sure customers really understand the value they're going to get before they even invest any amount of time. And we're doing it in a way that you need literally no skill set. You just need to get the hold of your data that you have internally in your company. And if you don't have that, we will supply you with sample data sets we've collected from around other institutions. So you can already experience AtomBeam, and then you pipe in your data and you can build your business case pretty quickly. And so
this is the management team, like right here.
Thank
Julien
you.
wanted me to take this out.
Right. Yes. I've cut my hair.
British, right?
So we've been hard at work. We are already now we've deployed the sandbox and the SaaS in our first sort of pre-production environment. We already have some early access customers evaluating the product. They'll be able to at the same time, they'll be able to also deploy it in their labs. And the important thing, we're doing this sort of early access so they can provide us with some valuable feedback on the product itself before we scale it across to all our customers. So that's why we're doing that.
Yep.
And then we're also my background is in space. And so we've been in contact with Zephyr as a company that is taking common off the shelf components like GPUs, used for AI, memory storage, and they making them hardened and space worthy. Traditional companies have their own sort of space hardened components, and the main thing is when you're in space, you have radiation, and the radiation tends to upset your memory and your processors by flipping bits, and so creates errors in your processors. So they've got some clever ways to reduce that. But this is also the interesting working with us, because we can not only help make the data that they'll need to store on these devices, on these satellites, smaller, but because I mentioned the intrusion detection and things, we also have a patent for improving error correction as well. So AtomBeam has multiple applications, makes data smaller, but also improves error correction, error recovery, which is also very important when you put components in space. And that same process we're doing in space, we can also apply it on the ground.
Right. Yeah. So, and this is just the beginning. I mean, there are lots and lots. So this isn't even mentioning like, half a dozen other companies that we're working with that in various stages that maybe have space-oriented stuff, some not space-oriented. And it's a matter of saying, okay, not only is it important from a competitive standpoint for them to incorporate compaction into their boxes, but it's also something that for us not only puts us into a position in which, okay, we have live customers and so forth, but these guys aren't the end users. They're selling to end users. So in effect, we are bringing their sales force online, selling our products, which is a good deal, right? I mean, all they do is they go out, they sell it. We're a component and we're getting paid when they sell it, but we don't have to do anything in terms of actually doing the selling part. It's a force multiplier, as the military calls it. Julien?
Yeah. So, I mean, we're also looking, you know, ultimately the long term is to enable this on chip so that it's just easy to deploy, and, you know, we can reach massive scales. I'm not going to go back to NVIDIA, but they are scaling massively through chips. So, we can then start making networks, you know, even more and more efficient, whether it's wide area networks or even local networks or even, you know, short networks, even within data centers. So we're exploring all possibilities. There are lots of different ways you can instantiate on chips. So we'll have to look at, you know, what's the fastest way, but also, you know, the way where we can convince people. So each of these involve a certain amount of investment that we will need to make. But we're definitely on track to get close and close to embed onto the hardware, which would get the next step once we embed in onto hardware as a software, is to move to on-chip instantiation. And that's another reason why we want to embed on hardware first, so that we can prove the case and quickly get interest from other companies that we can partner with.
Yeah, and we've done already the early work on FPGA. So just to be clear, an FPGA is a field programmable gated array, which means that you can fix stuff if you put it on there and you decide you need to tweak the software you put on it. You can do that, but they're really, it's dramatically more efficient to put it on a chip, because you can change what's working on a CPU, which is less than optimized, to something that's massively parallel. So it's doing a lot of things at the same time that you can't do even if you multi-thread on a CPU, because these are dedicated circuits, and that's what they're only supposed to do, this one thing, which means they do it really, really fast. And so and it becomes even more so when you move to an application-specific integrated circuit, or ASIC. And those are hardwired versions of chips. And that's where you get to eventually. The FPGAs we can address sooner rather than later. We'd like to do that, get really down the road on those starting this year. ASICs are going to be longer, and so is IP core, which is taking making a piece of a chip into AtomBeam code. And again, super efficient stuff, but also takes a while, and it's a longer term project. But FPGAs is not forever. So you want to talk about this? This is our final slide. So, and then we got to jump on the, we're going to have not enough time for the, get
yeah. I mean, I think, you know, Charles, you know, our vision is that, you know, eventually AtomBeam will be embedded absolutely everywhere in everything we do. And that's so when we set ourselves a vision as a company, this is, you know, the long-term vision where we want to be. And then we work backwards from there and say, okay, in order to get there, we need to be on chips. And then, you know, in order to get on chips, we need to embed on the hardware. And then, but before that, you know, we need to start convincing a few people that this is really cool tech. And that's why we're starting with SaaS. But SaaS is just the beginning.
Right. Yeah, that's right. I mean, if you really think about what this can be, it's like the very small size of the code and the high level of efficiency it has, and the universality that it has. You know, you can literally see this transforming every data center. If you can access reduced size data that's residing in a data center, and you could access it like it isn't reduced, I mean, that's like a total game changer. I mean, I can't tell you how big a deal that is, because everybody in all these data centers needs to access this data to do anything with it. So I want to look, all right, I've got a part overheating on my tractors or something, and I need to look at data over 5 years. Just finding it is hard to do. And once you find it, now you've got to pull it out, and you've got to look at a lot of stuff that isn't related to what you want just to get to this one thing. It can literally take days to find the information on there. And so that gets totally resolved if it's all in compaction. And it's hard to nail how important this is, but it is really. So with that, let's turn it over to Jeanette. And Jeanette, would you please get us rolling?
Yes, of course. Thank you guys for that. That was very informative. I know this is an hour-long webinar, so we do have about 10 minutes left to try to breeze through these Q&A questions that are coming in. If we do not get to your question, I will give all questions to Charles, and we will figure out how to answer them and get you those answers. I also just want to, oh, go ahead.
I was going to say, and also on the Start Engine site, so the reservations page, there is a discussion section. And if you go to that, you can post questions there.
Yes, thank you for that. So I just dropped in the Start Engine link. Reservations are live, but as Charles said, you can also go to the bottom where there's a discussion section, and you can also drop those same questions in, and Charles is very good about getting to those. So I'm just going to hop into it. This is from Mark Russell. Any updates on how earlier partnerships are using AtomBeam, Saab, Crosser, CrowdPoint, Cribble, etc.?
Yeah. So, I would say a lot of them were waiting for us to release the SaaS. In the case of Saab, they really would like to see it on an FPGA. And I think that in their case, they need to see, each one's an individual case, right? So Saab, one of their issues is they need to send images. And so for them, a combination of Compaction and Neurcom would be a huge resolution for them. But they also fit into the grander vision of the way that NATO, including the US, mostly sends data, which is over link 16 largely. There's other links, but that's the biggest one. And that is about 57 kilobytes per second, which means that it's about the speed of dial-up from the 1980s. And you've got 21st century aircraft flying around with gigantic amounts of data trying to push it through this tiny pipe. That's where, Saab is running into their issue, and we've had discussions already with DoD about it. That'd be a massive project because everything, ships, airplanes, tanks, people, everybody communicates over link 16. And if we could impact that, I mean, you're talking a pretty big number to fix that. So that's just one example. And there's, and Cribble's similar kind of thing. They really were interested in the SaaS, and now we're coming out with it. We're going to reapproach them. We're talking to various gateway guys, and, the list goes on and on with all these big companies. But the thing that Julian's talking about with the SaaS, that's the thing that we can go to back to a lot of these guys and say, okay, now we have what you were asking for.
All right, cool. Thank you. This next one is from Purang. How suitable is AtomBeam's compaction technology to be adapted for homomorphic encryption offerings as a future market sector for AtomBeam?
That's something Josh talks about. I don't know. I mean, I don't want to talk about it. But you can if you want, Julien. I don't know.
To be honest, I think it would be a great fit because like you explained, you'll still be able, you don't have to decrypt the data to retrieve your data, and it's exactly fits the AtomBeam philosophy. You don't have to decompact your data. You can access your data as is. So that's definitely something we will need to align with.
All right, thank you for that. This next one is from Daniel. What is being considered for quantum data?
We really haven't, I mean, Julien, go ahead, but we really haven't addressed quantum yet because there's nothing really to address yet in terms of commercial opportunity. But you want to add anything to that, Julien?
Let's not get Josh started on it because I'm sure with his error correction. I mean, quantum, one of the big things is how do you maintain error and error correction. So but it's quantum is also a very, very different paradigm in terms of data and how you look at the data. So it's definitely going to be, quantum is part of the research domain. So we're now into research of research.
All right, thank you. Next up is from Mark. What capability will your beta product have for release at the end of March?
Julien?
So it's going to be the core compaction, where people will be able to download an encoding small encoding software that they can put on whatever device they want, and that will encode the data, send it to the cloud, and then land it back into the customer's cloud. So that's what we're targeting at the end of March. But that's just really between that, but also the sandbox. So we talked about earlier about SAB and needing the SaaS will enable companies that want to move towards a chip to also evaluate and validate the technology, which will then get them excited to start investing more with us for those next phases. So the reason for doing the SaaS is to make it accessible to the whole world. And we will start with that piece of software. And then we're also looking at other partnership where customers will be able to just come online and buy the software and get it deployed on their devices then and there without having to do anything. Just a one-click buy deployment.
And it pushes out the software into the devices. That's part of what it does. And then to the extent that we need to update the code book, it does that. It measures it, figures out a new one, sends it out, whatever.
Yeah.
So everything's like the things that we've talked about for a long time that we've needed. These are all most of it. You can't say intrusion detection, but a lot of things have been built into it. There's a lot of guts to this thing. It's a complex thing, and it has to be completely thoroughly tested and sure and automated and have lots of UI business built in. So, but go ahead. Let's keep going. We're getting close.
All right, we are getting close. I'm thinking maybe 2 more questions, but we'll see. This one's from Adam. Welcome aboard, Julien. What are 1 or 2 aspects of AtomBeam's capabilities that you are more surprised and excited about since you joined?
Yeah, I mean, for me, it's kind of the simplicity of how the encoding works. But behind it is the complexity and how you decide what to encode and how you encode it. So it's that dual aspect of simplicity and complexity. So essentially where we're able to hide all that complexity away from the actual processing and from users. And as far as they're concerned, it's a very simple, let's just swap the patterns, the big large pattern with small things. So if you think about it, it looks very simple. But how you get there, how you manage that, it's actually it's quite smart, and there's AI obviously behind it. And we even sort of working on even furthering and simplifying that process so that it be completely seamless point to point between 2 devices. So and lots of exciting stuff for me coming. It's that, but also the fact that you can access your data in real time. That's also one of the things that dawned on me very quickly. I realized, oh yeah, okay, this is going to be good. And not only you can access the data, but it will speed up your query. So if you think about you're trying to query a large database, and yet that database is 4 times smaller, your query will go 4 times faster.
Yep. And one thing to mention before we go, we have a sign up list. How do you find it, Jeanette? So you can get for emails, we send out updates, things like that.
Yeah. So, you can definitely find us on the Start Engine page. Let me drop in let's see. So you can go to the AtomBeam website. I know you can sign up for any email list there as well. And, also the Start Engine offering AtomBeam page. I'll drop that in again. And yeah, any questions? I know there were some that we did not get to, so I'm sorry about that, but I have received all of them. I will give them to Charles, make sure that he does answer them. And yeah, this was great. I was going to try to squeeze one more in there, but we are with 1 minute left. Anything else that you guys want to say before we go?
I mean, for my part, actually, Julien, you go first, please.
No, I mean, I think, it's been very, very intense since I joined. There's a ton of work to be done. And it's just a matter of keeping the focus. And I'm really excited to see so many people joining the webinar and all these great questions. And some of these questions is prompting new ideas. And not like we needed more ideas, but I think we're getting more and more. So which is great. It's a good problem to have. Some people call it the champagne problem.
Well, yeah, I mean, I got to tell you, the thing that kills me about this whole thing is how fundamental it is, and how this could literally affect every connected device in the world and all the data centers in the world, and change everything to be more efficient, faster, all that. It's really an incredible potential. And so, and I got to tell you, having Julien on board, it's a revelation. It's huge for us. And so, yes, welcome aboard, Julien, from me too, even though it's not been exactly last week. So anyway. All right. Well, thank you very much. I appreciate everything, everybody showing up today and listening in.
Yes, thank you guys so much. And we will also have this as a webinar recap, so you guys can stay tuned for that if you hopped in late. But thank you guys, and have a good rest of your day.
All right. Look for it on
All
the AtomBeam YouTube channel.
Yes.
All right.
All right,
Thank
you
you.
guys, take
Thank you.
care. Thank you.
Bye.
Bye-bye.